In this video, we will be learning about set builder notation. So set builder notation is going to be another notation we use in sets. Set builder notation is very useful whenever we have really large sets or infinite sets, because the way the notation works is we have a curly brace to open our set, we have a variable to represent each element in our set, so I'll use x in this case. And then we have a bar to separate our variable from our condition. So our condition is just going to briefly explain what is x in this case. So what does our variable represent in this set? So let's say we were trying to figure out how to represent the set of all species of cats in the world. Well, so we'll say x is our variable to represent each element in the set, so each species of cat. And in our condition, we say what is x. So x is a species of cats. And then we close our set. So for this first lecture problem, it says using set builder notation, write the set f of all types of fruits. So we have our set name here, which is going to be f, and we need to denote a variable to represent each element in our set. So I'm going to use x, and we'll have our bar to separate our variable from our condition. And our condition here is x has to just be a type of fruit. So we'll say x is a type of fruit. And that's going to be your answer. So for the second lecture problem, it says using set builder notation, write the set A of all types of animals. So our set name here is going to be A, and I'm going to use x again to represent each element in our set, and our condition is x has to just be a type of animal. So we'll say x is a type of animal, and that's going to be your answer. Hey everyone, before we get back to the video, I just want to give a reminder to like the video if you enjoyed it, leave a comment down below if you have anything to say about the video, hit the subscribe button to stay up to date with some of the content I post, and to turn on post notifications to be notified when I upload. Thank you. So let's do some practice problems to help us get better at representing sets in set builder notation. So for this first practice problem, it says represent each set using set builder notation. So we have the set P of all types of planets. So our set name here is going to be P, and I'm going to use x to denote each element in our set, and our condition is going to be x has to just be a type of planet. So x is a type of planet. So this is going to be your answer. So for the second practice problem, it wants us to represent the set G of all galaxies in the universe in set builder notation. So our set name is going to be G, and x is going to represent each element in the set. So our condition is x just has to be a galaxy in the universe. So x is a galaxy in the universe. So this is going to be your answer. So for this third practice problem, it wants us to represent the set n of all integer multiples of 5 that are greater than 0 in set builder notation. So our set name here is going to be n, and we're going to open our set. So I'm going to use x to denote each element in our set, and our condition is x just has to be an integer multiple of 5. So x is an integer multiple of 5, and it also has to be greater than 0. So I'm running out of room, so I'll just keep writing down and greater than 0. So as you can see, we did have to write a lot, and there is a way we can actually represent the set more defined. We can put this in essentially math terms. So this is still a correct answer, but let's try to get a more defined and clear notation of the set. If we want to represent this answer in a more defined version, we can say set in, and then we have our variable x. Now, the first thing I want to do is represent the set in. Let's represent it in roster method. So if we would have to do it in roster method, our elements are going to be integer multiples of 5. So that means 5 times 1, which is going to give us 5, 5 times 2, which is going to give us 10, 5 times 3 is going to give us 15, and it's going to go all the way to infinity. So we can notice here that the pattern is going to be 5 times 1, 5 times 2, and 5 times 3. Well, if you notice, these numbers have in common is we're multiplying by 5 each time. So for our variable that's going to represent each element in our set, we can say that it's going to be 5 times x. Now, we have to establish in our condition what is x going to be. Well, we can see that x is going to be numbers like 1, 2, and 3. So we can say that x is going to be a natural number, because natural numbers are going to be numbers like 1, 2, and 3. Sometimes natural numbers will include 0, but for this case we'll say that it doesn't include 0. So natural numbers, the range is going to be from positive 1 all the way to infinity, which agrees with our set that we wrote here in roster method. Here we're going to infinity. So we can say that in our condition x is a, and then write the notation for natural numbers. So then we close our set, and this is going to be your answer. So for this fourth practice problem, it wants us to represent the set T of all integer multiples of 7 that are greater than 0 in set builder notation. So we have our set named T, and it's very similar to the previous problem. So we're trying to represent integer multiples of 7 that are greater than 0 all in one set. So we can say 7x is going to be our variable here, because remember, integer multiples of 7 all are going to have 7 in common. So we can just put 7 in our variable. And then our condition is integer multiples of 7 are going to be 7 times 1, 7 times 2, 7 times 3. So natural numbers are going to be numbers like 1, 2, and 3, and so on. So we can say x is a, and then use the natural number symbol here, and then close our set. So this is going to be your answer. So for this fifth practice problem, it wants us to represent the set f of all fruits that are citrus in set builder notation. So we have our set name f, and we're going to use x to denote each element in the set, and we'll say x is a fruit that is citrus, because that's our condition for our elements. So x is a fruit that is citrus. And then close our set, and that's going to be your answer. So for the sixth practice problem, it wants us to represent the set O of all odd numbers in set builder notation. So first, let's try to understand what odd numbers are. So odd numbers are going to be numbers that we can't divide by 2 and get a whole number back. Even numbers are going to be numbers we can divide by 2 and get a whole number back. So if we had to write the set of even numbers in roster method, it would look something like this. And I'm only going to do the positive version. So it's going to be 0, 2, 4, and so on, which means it'll just go to infinity. Now, if I had to write the set of odd numbers, and we'll do the positive version, it'll be 1, 3, 5, and so on. Now, let's analyze what's the differences between these numbers. So, even numbers are going to be going up by 2 each time. So essentially what we can say is it's really just a multiple of 2 each time. So it's 2 times 0, 2 times 1, 2 times 2, and so on. So the number here that we're multiplying by 2 is just going to go up by 1. Well, if you look at odd numbers, what's the difference between this number here, so 2 times 0, from this number? What's the difference between 2 times 1 to 3? What's the difference between 2 times 2 to 5? Well, if you notice, 2 times 0 is going to give you 0. And if we link it to the 1, the difference between those two is just going to be plus 1. So 2 times 1 is going to give you 2. So how much difference is there from 2 to 3? It's only going to be plus 1. 2 times 2 to 5, it's only going to be a difference of 1. So if you notice, we just have to multiply a number like 0, 1, 2, 3, and so on by 2 and add 1 to get an odd number. So we can write it something like this. So we can say 2 times x plus 1 is going to be our variable in our set of odd numbers. Now, if we have to include the negative versions of the even and odds that we wrote in Rosser method, it would look something like this. So it'd be -2, -4, and then we have it goes to infinity, and so on. For the odd set, we have -1, -3, and so on. So if you notice, it's still going to do 2 times a number. So in this case, to get -2, it's 2 times -1, and for 4, it's 2 times -2. So we're still going to add 1 to whatever that number is. So 2 times -1 is going to give you -2, plus 1 is going to give us -1. The same goes for 2 times -2, plus 1 is going to give us -3. So if you notice that these numbers that we're multiplying by 2 are also going to have to be negative. So a good condition to suit this would be x has to be an integer, because integers are negative and positive whole numbers, and this also includes 0 as well. So if we want to write this set in set builder notation, we can say that set O, it's going to have the variable 2x plus 1, and then our condition is x is a integer. So the integer symbol is z, and this is going to be your answer.